Okay, more low-tech math. There's my shape. I want to get it down here. So what am I going to do? It looks like I'm going to slide it back here. I'm going to then rotate it 90 degrees. So I'll just put a axis in here just so I can keep track of it a little bit better. This point, I'm going to rotate it 90 degrees counterclockwise about the origin. So that point right there stays fixed. All right, so once I've done that, boom, it's going to be right there. Now, it looks like this is smaller, and if I calculate this out, it looks like this is half the size of this. Okay, it's both half the size horizontally and half the size vertically, so it's a dilation with the center at the origin. You can center at the origin here if we want, by a factor of 1/2. That's going to shrink this thing down. It's going to make it a shrinky dink. It's going to keep this point centered still right there. Okay, so that's really important. That's one of the reasons to move it back to the origin, is so that you can kind of know what's happening with this. It controls it a little bit better. All right, so once I've got this thing down to 1/2 the size, now this point is going to have to go right to there. So that looks like I have to go over 10, and then it looks like it's down 5, let's see here, down 6, 7, 8, 9, 10, yeah, so it's going to have to go over 10 and down 6. All right, so that's the plan. So let me run through it again. Back to the origin. Gonna rotate. Oh, hold on, let me see. I think I did that differently. You can do it differently. I'm going to move this guy back to the origin. Okay, so that's the point I'm going to keep fixed. I'm going to rotate it here. I'm going to dilate it by a factor of 1/2. It's going to shrinky dink it down to this size. Then I got to move this point, if I want, right over to here. I'm just going to match up the points. So that's over 10 and down 6. All right, so let me see if I can write those. All right. Translate that guy back to the origin. Translate back to the origin. So that's going to be translate left. Oh, yeah. Left. And it's this point right there, so left 10. I'm going to rotate 90 degrees counterclockwise about the origin. You have to say about the origin, otherwise you don't know what center you're spinning this thing around. Okay. The next thing I'm going to do is I'm going to dilate it. This is the shrinking part. Dilate by a factor of 1/2. Okay, so that's going to have it. You can see this. It's going to have it right here, but shrinky dinked. Then I have to move it over 10 and down 6. All right, so over 10 and down 6. So move. So then I'm going to translate. It's easy to get translate and transform confused. Translate right 10. And down. Let's see, I think we said down 6. This is going to be a little bit tricky. Hold on. Now I really want to check that. Yeah, that's good, because this point's still stationary. I was thinking this guy's going to shrink and I have to be careful, but it's really good to look at this point. So if I move this point over 10 and down, it's going to be right there, but all the other stuff's going to shrink around there. So over 10 and down 6. Okay, so I'm going to write the equations for this. Let me see if I can do this and look at this at the same time so you guys can see it. All right, so translate left 10. So let's start xy. That's going to go to left 10. Okay, y. And now I'm going to rotate it 90 degrees counterclockwise. So that makes this the opposite y, x minus 10. So that's my rotation. Dilate by a factor of 1/2. The opposite of 1/2 y, x minus 10. Translate right 10. negative 1/2 y plus 10. Now, it says y here, but it's in the x value. It's in the x location. I know that's a thing that you have to get your brain wrapped around. And then down 6, so it's going to be x minus 10 minus 6, so we can just say x minus 16. And that should be my one-step transformation equation to take this guy to that guy.